Lesson 14.10, solve 2 by 2 system of equations with matrices. And so let's read the directions first, and I'll explain it a little more. It says write an augmented matrix, which is what we did in the last lesson, and use elementary row operations in order to solve the following system of equations. Your final matrix should be in reduced row echelon form. So let's talk about what this is. Reduced row echelon form. That is going to look a certain way, and that's how we're going to know we're finished. And the way that it looks is it's going to be a 1, and then a 0, and then a 1. Then we're going to have the dash or the line in between, and I'm just going to say A and B. So let's think about what this means. This is in place of the x. So we're going to have 1x plus 0y equaling a number. Well, 0y wouldn't be there, so this really gives you what x equals. So x would equal whatever this number is. Next row would be 0x plus 1y is needing to equal a number. So that would go away. Really, that's y equals a number. So this is our end goal here. Because our whole goal is to get x and y coordinates because we're trying to see where these two lines cross. Now I'm only doing this for the 2 by 2s because once they get bigger than that, like the 3 by 3s, it's a total pain in the butt. So these I don't mind too much. They're kind of like a little puzzle. But again, we won't do very many of them. I just need you to see it. So going back to our elementary row operations, basically, what are the things that we can do, the operations, to get it into this? We can interchange 2 rows so we can swap things, but we have to do the whole row. We can multiply by some kind of constant, and we can add a multiple of one row to another. We can add rows together. So the first thing you want to do is write your augmented matrix where it's just the coefficients. I'd be -1, -1, -1, 4, 2, -10. And then you can put your dash line here to show you these are the constants. That gets kind of confusing. I'm actually going to make a solid line. Okay, so I'm looking at this, and I'm trying to figure out how to get my zeros first. And really, I kind of like getting this 0 very first. It just seems like it works out better that way. So let's think here. How could I get a 0? Well, if this is a 4, and this were a -4, they could add together to make 0, but I would need this to be down here. I guess I don't have to. So let's go ahead and actually first take row 1 times 4. Okay, so I'm taking everything in row 1 times 4. So that would now be -4, -4, -4, and leave row 2 alone. 4 to -10. Okay, and now because I want a 0 here, I'm going to add row 1 to row 2 to get a new row 2. So the easiest thing for me to do is think, well, I'm not changing row 2, so I'm going to leave the row 1 numbers the same, the -4s. Okay, so then I'm adding, though, to get my new row 2. 4 plus -4, -4 plus 4 is 0. -4 plus 2 is -2, and -4 and -10 make -14. So I now have the 0 where I needed. So that's good. Now let's try to get this 0. So what could I do to make that -4 0? Well, I could take row 2 times a -2, and that would be a +4. So I'm going to do that next. So I'm going to take row 2 times, I want it to be a -2 so that I can get it to be the opposite sign. So I'm not doing anything to row 1. I'm going to write the -4s again. Okay, everything times -2, that would be a 0. That's why you want the zeros first, because then once they're 0, they stay. -4 times, or -2 times -2 is +4, and -2 times -14 is +28. Okay, so now I can add row 2 to row 1 to get a new row 1. So row 2 is not changing, my 0, 4, and my 28. But we're going to add. So negative 4 plus 0 is still negative 4. Negative 4 plus 4 is 0. And negative 4 plus 28, or 28 minus 4, is 24. Okay, so now I've got these two good. Now I need to focus on getting these to be 1. So let's look at the first row. To get it to be a 1, you're going to want to multiply, because again, we can't divide. But really, I think of, what do I divide by? Well, I want to divide by this number, negative 4. But instead of dividing by negative 4, I'm going to multiply row 1 up by negative 1/4. So dividing by negative 4 is the same thing as multiplying by negative 1/4. So negative 4 divided by negative 4, that's 1. 0 divided by negative 4, or negative 1/4 times 0 is 0. Negative 1/4 of 24, or 24 divided by negative 4 would be negative 6. So that's looking good. I did not change my row 2. So now I've got my 1 in the right spot and my zeros. All I got to work on is the 4, and that's pretty easy. You're just dividing by 4 or multiplying by 1/4. So multiply row 2 by 1/4. So that would still be a 0. 4th of 4 is 1, and 28 divided by 4 is 7. All right, so there we go. That then tells me that x is negative 6 and y is 7. Now again, this would not be my preferred choice, because if we think about all we're doing is trying to figure out where two lines are intersect, I could simply put these equations on Desmos and graph them and see where they intersect. I could do elimination method, which is where I try to get something to eliminate here. So I could take this whole thing times 4 to make my x's eliminate, or times 2 to make my 2's eliminate. So this is definitely not the fastest thing, but again, I need you to see it so that when we do it later, you know the process. Let's go ahead and try number 2. Go ahead and write your augmented matrix. And I'm going to try to get this 3 to be a 0 to start. So if I can multiply this all by negative 2, that would be a negative 6 and could add. You could actually do that in one step on Delta Math. You could say I'm going to add a multiple of one row to another. The thing is that I kind of make a stupid mistake doing that, so I'm not going to. I'm going to do step 1, multiply row 2 by negative 2. So I'm keeping row 1 the same. That would be negative 6, 16, positive 2. Now I'm going to add row 1 to row 2 to get a new row 2. So keep row 1 the same. So that would be 0, 13, and 0. All right, now we want to get the negative 3 to be a 0. This one's kind of hard. I don't see really anything easy here. Think about elimination method. These two numbers, 3 and 13, have a least common multiple of 39. So if I took the top one times 13 and the bottom one times a 3, that would make that be a negative 39 and a positive 39. That's what I'm going to do. So it's really 2 steps, but I'm going to do it at once just to save paper and time. So multiplying row 1 by 13 and multiplying row 2 by 3. 13 times 3 is 39, and then negative 39. Wait, I just did 13 times 3. I meant 13 times 6. 78. There we go. And then 13 times negative 2 is negative 26. That would be 0, 39, 0. Okay, then I'm going to add row 2 to row 1 to get a new row 1. So row 2 is going to stay. 78 plus 0 is 78. That makes 0, and that would still be negative 26. Okay, so I got my zeros where I need. Now I just want to make the other ones be 1. So I'm going to have to divide 78 by itself or take it times 1 over 78. Same thing here. I'm going to have to divide by 39 or take it times 1 over 39. So that's like number 6 and 7. Multiply row 1 by 1 over 78, multiply row 2 by 1 over 39. So then that would get me 1, 0, negative 26 divided by 78. Turn that into a fraction, but you should know that's negative 1/3. So you can get some fractions on here, but they should be not terrible fractions. That would be 0, 1, and 0. So I'm done because I have everything I need. That tells me that x is negative 1/3 and y is 0. That's it. So that's called reduced row echelon form, manipulating it until you get this 1, 0, 0, 1 pattern, and this is your x, this is your y.